Welcome. Today we're going to talk about prisms and how to find their surface area. First things first, what on earth is a prism? Well, a prism is a polyhedron with two congruent polygon bases that are parallel, and then rectangular faces that connect them. Then another quality that prisms have is that if you take a cross section of the figure, it's basically a slice through the middle, but if that slice is parallel to the bases, it will also be congruent to the bases. So let's look at some examples. What is a prism and what isn't? If you saw our first video just introducing 3D shapes, we had a whole bunch of 3D figures that were categorized as either polyhedra or circle-based shapes. Out of all of those, our cube is a prism, but the pyramid is not, and the dodecahedron was not, the cylinder was not, and the cone was not, and the sphere was not. So you might wonder why we actually look at prisms if only one of our shapes was. But those were just the examples from that first video. There are lots of other types of prisms. We could have a triangular prism, or we could have a cuboid, which is more like just a rectangular prism. And okay, so the bread is maybe a little bit of a joke, but it's the right idea. You imagine the ends of the bread are congruent, and kind of imagine that it's parallel sides going along, and you imagine all those slices that are parallel to the heels, and all those slices are congruent also. So it kind of fits the properties of a prism. It's not actually a prism, but it illustrates that cross-section idea. When we're finding surface area, since prisms are polyhedra, all of their surfaces are flat shapes. So to find the surface area, you merely find the area of each flat shape, or each of the faces, and just add them all together. Here's our first example. Let's find the surface area of this triangular prism. And really, our steps are just going to be to find the area of each face. Let's start with this triangular base at the front. Now we know to find the area of a triangle, we use 1/2 times base times height. So our base is 4 centimeters and our height is 3 centimeters. We'll fill those numbers in, and then 1/2 times 4 times 3 gives us 6. So the area of our first triangular base is 6 square centimeters. Let's look at our second triangular base, all the way in the back. It's exactly the same. You don't have to recalculate. You know those bases are congruent, so if the first one was 6, the second one is also. Let's shift and start looking at some of these rectangular sides that connect the triangular bases. So this one's in the back, but it is a rectangle. It looks a little like a parallelogram here, and that's just from the 3D drawing. If you have a model of like a triangular prism that you can actually hold, you'll see that if you turn it, it's actually a rectangle that's there. But even if it were a parallelogram, we find the area in very similar ways. So we'll use length times width on this rectangle. The length is 5 centimeters and the width is 3. Plug those numbers in and we get an area of 15 square centimeters. Now we have a lot more to do still. We already have these 3 sides, but really there's going to be 5. There's 2 bases. Each of the bases has 3 sides, and we know there's a rectangle for each of those sides. So the 2 bases plus 3 sides, we're looking for 5 face areas. We've got 3. Let's look now at the rectangle on the bottom. Now, again, length times width. So 11 is a length, 4 can be our width. Plug those in, and we get 44. The last rectangle is maybe the hardest one to see in drawings like this, but it's that slanty one that goes from the top down to the bottom, kind of along the hypotenuse of our triangle. So it is still a rectangle. We'll still use length times width. We'll use that 11 again, but now we're going to use the 5 that went along that third side of the triangle. So 11 times 5, and we get 55. So we have found all of the areas of the different faces. Now we just need to total them up. So we add these all together, 6 plus 6 plus 15 plus 44 plus 55, we get 126. Now, of course, before we go to final answer, we need to get our units on here. Since this is an area unit and our length measurements were all in centimeters, we'll do centimeters squared. And that's our example 1. Pretty simple, huh? Now, of course, if your area calculations on each of those faces gets more complicated, the overall problem gets more complicated. So let's look at one that's a little more complicated. Example 2. We're going to find the surface area of this hexagonal prism. So notice that the hexagonal bases are regular, which means that all of the rectangular faces are congruent, because that distance, that length between the bases, is always going to be the same. And since the sides of the hexagon are the same, that means the width of all those rectangles are also the same, and we're going to use that as kind of a shortcut. So let's get started with finding the area of the first hexagonal base. Now, if you remember from our area of a regular hexagon video from the last playlist, our area formula for any regular polygon is the area equals n, the number of sides, times 1/2 times s, which is the side length, times a, which is the apothem. Now, since this is a hexagon, n is going to equal 6, so we know that part. Then we're looking for s. In our formula, s is 6 inches, so in this picture it's showing 6 inches is the side of that hexagon. And lucky for us, they already tell us the apothem is 5.2. So we don't have to do any crazy Pythagorean theorem or trigonometry or anything. They've already given us all the pieces we need for our calculation. So we'll just fill in those pieces. 6 times 1/2 times 6 times 5.2. 6 times 1/2, I always like to do that 1/2 part first, get that fraction out of the way, so I'm going to rewrite this as 3, that was 6 times 1/2, times 6 times 5.2. Also with decimals, I like to use parentheses to show my multiplication instead of the dots, because I get confused on the dots sometimes. But once we multiply all those together, we get 93.6 as our area of the first hexagonal base. Now remember, the second hexagonal base is congruent, so it's also 93.6. Let's look now at all of those rectangles that connect our hexagons. So I'm going to look at this one on the back because it actually has the measurements on its own edges, so we'll use that one. Of course, rectangles, we use length times width, so we'll use 6 times 25. 6 times 25 is 150, so our first rectangular face has an area of 150 square inches. Now, there were 6 sides of this hexagon, which means there are 6 of these rectangles. So if I take that 150 and multiply it by 6, that 900 covers all of our rectangles. So instead of looking at just one and then calculating again for the second one and again for the third one, so on and so forth, we can just multiply since we know they're going to be congruent based on the fact that we had a regular hexagon as our base. So now we can go ahead and add these up. Our total surface area, we're going to add the 93.6, the other 93.6, and the 900. And we get our surface area adding up to 1,087.2. And of course, before we circle this as our final answer, we need our units there. Since our lengths were measured in inches, our area is square inches. And there you go. So now we've found the surface area for a couple different types of prisms. The strategy really is just to find the area of each of those flat faces and just add them up. So thank you for joining me today, and I will see you next time.